Imagine waking up to find a message in a bottle floating in your backyard pool. Except this bottle didn't come from your neighbor, or even your country. It came from another continent, maybe another ocean. Now scale that up to space. This month, astronomers found something drifting through our cosmic neighborhood, a third known object from another star. It's not science fiction, it's not a UFO, it's real, and its name is 3I Atlas. Hey, I'm Dory, and welcome to Metalog, your guide to the universe, one paper at a time. This is the show where we break down peer-reviewed science like it's poetry from the stars. If you're a fan of cosmic mysteries, planetary puzzles, or just love wondering what's out there, go ahead and like this video and hit subscribe. Because today we're diving deep into the story of 3I Atlas, the latest interstellar visitor to pay our solar system a fleeting, mysterious visit. Let's rewind the cosmic clock for a moment. In 2017, astronomers spotted a strange, fast-moving object cutting through the solar system. It wasn't orbiting the sun. In fact, it was doing quite the opposite, flying past and heading back out to the void. That object was named ʻOumuamua, which in Hawaiian means scout or messenger from afar. Appropriate, right? Then in 2019 we found another one, 2I Borisov. Unlike ʻOumuamua, which looked more like a dry asteroid and showed no comet-like activity, Borisov was active. It had a coma, a dusty tail, and it was outgassing like a textbook comet. But it didn't come from our solar system either. Its velocity was too high, its trajectory too strange, another alien. These two objects changed the game. They showed us that material from other star systems, fragments of other planetary nurseries, can and do occasionally visit us. For a long time, we thought these encounters would be incredibly rare, maybe one in a lifetime. But now, in 2025, we've spotted a third, 3I Atlas, and it's got scientists rethinking how often these cosmic travelers might be dropping by. Here's the mystery. Why are these objects showing up now? Have they always been flying through and we just didn't notice? Or is something changing, either in space or in how we're looking? Let me give you an analogy. Picture standing in a forest with a flashlight. If you point it straight ahead, you might only see a few fireflies. But if you widen the beam and sweep the trees, suddenly you notice they're everywhere. Our astronomical tools have become better flashlights. Atlas, the Asteroid Terrestrial Impact Last Alert System, is one of those sweeping tools. It's a sky survey system designed to scan the night sky for near-Earth asteroids. But every now and then, it catches something much stranger. That's how 3I Atlas entered the story. But unlike the slow-burning mystery of ʻOumuamua, this one revealed its interstellar nature almost immediately, and that's because of its speed. So how did astronomers find it? On July 1st, 2025, the Atlas telescope in Chile noticed a moving object against the backdrop of the dense Milky Way. Not exactly the easiest place to spot something. Imagine trying to find a drifting balloon in a crowded city skyline. But the software flagged it, and within 6 hours, astronomers all over the world started pointing their telescopes. It wasn't just a local fluke. It had been spotted in older data too. Observations from May and June, from systems like ZTF, the Zwicky Transient Facility, showed the object had been there all along, just unnoticed. Once they traced its trajectory and velocity, the verdict was clear. This was not from here. Let's talk numbers, but in story form. Imagine our sun holding Earth in orbit with a gravitational leash. Most objects that stay in the solar system follow elliptical paths, like stretched rubber bands. But 3I Atlas doesn't loop around. Its path is hyperbolic. That means it's coming in fast, making a sharp turn near the sun and then escaping forever. Its speed as it enters the solar system? About 58 kilometers per second. That's faster than any spacecraft we've launched. And its orbital tilt, about 175 degrees, means it's coming in almost opposite to the general spin of our planetary family. It's like someone walking against the flow of a marathon. Even better, they got visual data. Using the Very Large Telescope in Chile, astronomers captured high-resolution images that revealed something remarkable: a faint coma. That's the glow you get when sunlight heats up a dusty, icy body and causes it to shed material. So now we have something that's not just interstellar, but active. First, the object is active, but subtly. It's shedding dust and gas in a way that suggests it's made of ices and primitive materials. That already gives us a clue. This object might have formed in the outer regions of its home star system, much like comets here. Second, it's red. Not literally like a fire truck, but in terms of light reflectance. Using multiband imaging, basically measuring how much light it reflects at different wavelengths, astronomers found that 3I Atlas has a moderately red spectral slope. This puts it in line with things like D-type asteroids and some comets. That might not sound exciting, but color tells us about composition. A red slope hints at complex organics and carbon-rich materials, stuff that forms far from a star in the cold and dark. Third, it's stable. Over several days of observations, its brightness didn't fluctuate much. That suggests it's either not spinning fast or the coma is masking any rotational signature. Remember, ʻOumuamua had wild brightness variations. It tumbled like a chaotic baton. But 3I Atlas seems chill, steady, maybe even spherical. And finally, the lack of sharp spectral features. No emission lines or absorption dips means it's not actively venting lots of gas. That matches what we'd expect from a faintly active comet. Put all this together and what we have is a puzzle piece. A clue about how planetary systems elsewhere might evolve. Atlas seems to confirm that other stars like ours form icy small bodies in their outskirts. And sometimes those bodies get kicked out, flung into interstellar space by gravitational nudges or planetary migrations. This one made it across light years, only to swing by our sun for a few short months. And because it's active, we can study its coma, its dust particles, maybe even its chemical makeup, and compare that to what we see in solar system comets. It's the closest we'll get to scooping up a sample from an exoplanetary system without ever leaving Earth. But here's what keeps astronomers up at night. We've now seen 3 interstellar objects in under a decade. That's not what we expected. The models said these would be rare. So either something's off in our models, or we're on the verge of discovering that space between stars is full of debris, maybe even more than our own solar system. Also, each object is different. ʻOumuamua, weird shape, no coma. Borisov, traditional comet. Atlas, somewhere in the middle. Why? Are there different classes of interstellar objects? Are we seeing a selection bias, only catching the large, slow ones? What about the tiny ones we miss entirely? And here's the wildest part. Atlas will be at its most active near the Sun, but Earth-based telescopes won't be able to see it. Why? Because it will be lost in the Sun's glare behind the solar disk. We'll be staring at daylight while it passes closest. Unless we turn to Mars. Yep, the object is passing within 0.19 astronomical units of Mars in October. That's super close in cosmic terms. If a spacecraft orbiting Mars has the right instruments and timing, we could get direct data. Imagine that. Interstellar science from Mars. So, here's the takeaway. Atlas is not just another rock. It's a story. A tale of cosmic migration, of icy bodies born around distant stars, kicked out into the void and drifting through space for possibly millions of years, until they stumble upon our sun. Every time we find one, we rewrite our understanding of the galaxy. These are not just stray comets. They are ambassadors, messengers, fossils from worlds we may never see. And who knows? The next one might carry more than dust. It might carry amino acids or water or something that makes us rethink where life could begin. If you enjoyed this journey through time, dust, and stars, drop a comment, share the video, and stay tuned. The universe is talking. We just have to keep listening. I'm Dory, and this was Metalog. See you next time.